Welcome back students for the lecture series of the Introduction to Analytical Chemistry. So let's get started. Now we see determination of molecular formula. So first we see what is the molecular formula. A chemical formula which gives the total number of atoms of each element in each molecule of a substance, or formula which indicates the actual number of atoms of the constituent element in a molecule. Now we see the percent composition. So it is defined as the ratio of the amount of each element to the total amount of individual elements which are present in the compound and multiplied by the 100. This is the point you have to remind, that if the percentage total is not 100, then the difference is considered as percentages of oxygen. From percentage composition, the ratio of the atom of the constituent element in the molecule is to be calculated. Now we see about empirical formula. For this, the simplest ratio of atoms of the constituent element in the molecule is called empirical formula of that compound. From empirical formula and molecular formula can be obtained if the molar mass is known. Now we see some examples regarding empirical formula and molecular formula. So first example is, a question is that a substance on analysis of the following percent compositions: sodium is equal to 43.4%, carbon is equal to 11.3%, and oxygen is equal to 60%. Calculate the empirical formula. So atomic mass for sodium is 23, carbon is 12, and oxygen for 16. So the solution for this example, you have to draw first this type of table. In that some heads are there: elements, percentage by mass, atom in gram, atomic ratio, and simplest ratio. So we have carbon, oxygen, and sodium. So carbon have the 11.3% given, oxygen 40, here note that not 16, here 45.3 is there. Okay, please check it out. Instead of 16, please take 45.3 for this oxygen percentage, and sodium 43.4% is there. Okay, so we have to calculate first atom in grams. So for that, here 11.3 upon 12, 12 is the atomic number, so it comes out to be 1. 45.3 upon 16, it comes out to be 3, and 43.4 upon 23, it comes out to be 2. So again, then we take atomic ratio. For the atomic ratio, you have to consider the smallest atomic in grams. So here smallest atomic in gram is the 1. So for this, these 3 atomic in gram divide by smallest atomic gram, that is 1. So here 1 is came, and 1 divide by 1. Why? Because it is smallest one. So 1 upon 1 is equal to 1. 3 upon 1 is equal to 3. 2 upon 1 is equal to 2. The simplest ratio is 1, 3, and 2. What is meant by simplest ratio? For means carbon is present only in 1. Carbon is present, the atom of the carbon is only 1. The atom of oxygen is in 3, and sodium is equal to 2. So the empirical formula for this, Na2CO3. Why? Because sodium have the 2, hence Na2, then C, and then O3. Now we see again one more example for this. The example is compound content 4.07% of hydrogen, 24.27% carbon, and 71.65% chlorine by mass. Its molar mass is 98.96 gram. So what is its empirical formula? Atomic masses of hydrogen, carbon, and chlorine are 1, 12, and 35.5 respectively. So now we see the solution for this. So step 1, in that you take the total number of carbon, hydrogen, and chlorine. So 4.07, so it comes out to be 99.99. So near about it it is the 100. And if there is no need to consider presence of oxygen atom in the molecule because the sum is 100. Step 2, in that you have to draw a table under the heading element, percentages by mass, atom in gram, atomic ratio, and last one is the simplest ratio. So the percentages by mass given for the carbon is 24.27 in example, for hydrogen 4.07, and for chlorine 71.67 is given. Then we have calculate the atom in gram. For that, given percentages by mass, divide its atomic mass. So carbon have the atomic mass 12. Okay, so 24.27 upon 12, it comes out to be 2.0. For hydrogen it comes out to be 4, and for chlorine it comes out to be 2.0. So now we take the atomic ratio. For atomic ratio, you have to consider the smallest value in atom in gram, and then divide each atom in gram. Okay, so in atom in gram, the smallest is the 2.0225. So you just divide it, 2.0225 into 2.0225, it comes out to be 1. For 4.07, divide 2.0225, it comes out to be 2. And for 2.021 upon 2.0221, it comes out to be 1. So the simplest ratio is the 1 as to 2 as to 1, means the atom of the carbon present 1, the atom of the hydrogen present is 2, and the atom of chlorine present is in the 1. Step 3, in that we have to write the empirical formula. For simplest ratio is, here C is 1, so C, H is 2, so CH2, and chlorine again is 1, so CH2Cl. CH2Cl is the empirical formula. Now we want to calculate the molecular formula. For moving for that, step 4, writing the molecular formula. There are the 3 steps. So first step is the calculation of empirical mass. So for this, our empirical formula is CH2Cl. So carbon have the atomic mass 12. So 12 into 2, here into 2, plus 1.008 plus 3.435. So it comes out to be 49.48 gram. Next is the calculation of R. So R is equal to molar mass to the empirical formula mass. So it comes out to be 2. And the molecular formula, lastly we calculate the molecular formula. The formula for this, R into empirical formula. So 2 into CH2Cl. So it comes out to be C2H4Cl2. One more example, that calculate the percentage composition of constituent element in the lead phosphate. Okay, for this, so the molecular mass of lead phosphate we have to consider first. So 3 lead present is in the 3, so 3 into Pb, 2 into phosphorus plus 8 into oxygen. So atomic number for the Pb is the 207, for phosphorus it is 31, and for oxygen is the 16. So it comes out to be 811. Next step is the to calculate the percentages of Pb first. So for that we have considered the ratio in between the atomic mass of lead to the molecular mass of lead phosphate. So it comes out to be 76.57. Now we have to calculate the percentages of phosphorus. For this, again this formula we have taken 31 for the phosphorus, so that it comes out to be 7.64. And last one is the percentages of oxygen. So 100 minus percentages of lead plus percentages of phosphorus. So 100 minus percentages of lead is the 76.57, and lead percentages of phosphorus is the 7.64. So it comes out to be 15.79. So in this way we have calculate the empirical formula, then from empirical formula we calculate the empirical mass, and from empirical mass we calculate the molecular formula. And also we had to calculate, we also able to calculate the constituents, percentages of constituents which are present in that formula. Okay, so now it's your turn to calculate the percentage composition of constituent element in the potassium dichromate.